Okay, we're going to talk about disk queues tonight. One of the things I find that gets pretty misunderstood or not known at all is how to analyze disk queues properly. And I find that a lot of admins, a lot of DBAs, they know to look for disk queues, but they don't know really they don't really know what a good disk queue is, and that's what we're going to talk about. And this will be fairly short. This is going to be a very specialized a very short specialized video. I do have another video on general performance monitoring basics, and it explains, perfmon and task list and all of those things that you can look at. It's Windows performance monitoring part 1 and 2, I believe. But for right now, I'm just going to talk about disk queues and assume that you know all that other stuff. So if you come in here, and we're just gonna talk about disk basics just a little bit here. Come into perfmon. I'm going to expand this a little bit. There we go. Now, I get the average disk queue, and the average disk queue is for it's for the sample period, right? But what I want to do here is I want to add. I like current disk queue better, especially when I'm watching it live, right? So if you come over here, now I've got a choice, right? Get over here. I've got a choice. I can choose physical disk, or I can choose, come up here, logical disk. And quite a few people don't know the difference. A physical disk is an actual physical hard drive. Okay, it's in the name, right? A physical disk. A logical disk is a single disk that is chopped up into separate partitions. So you can see here that on my logical disk I've got C, D, E, and G, right? Or I could do the total. On my physical disk, wherever you are, there you are, you can see that I've got E, C, D, and G are all on the same physical disk, right? And that's really going to matter, because if you've got, a physical disk, that's one thing. If you've got a logical, a physical disk is pretty easy to troubleshoot, right? You've got one disk, or you've got separate disks, but they're physical disks, and you know that you've got your data files on there. Well, that's pretty easy to troubleshoot. You know that your problem is data. You know that your problem is data file contention, right? Or maybe you just don't have enough spindles thrown at it. But if you've got a logical disk, and you take the total, and you've got data and tempdb and logs and everything split across these partitions, because you want to be able to logically separate them, right? You just want to keep them separate so it's easier for you to find them. Then by taking a total, it's going to show you the disk queue for every single one of them, and you're not going to know which individual file is giving you the problems. And this is a high-level example, but you get the idea. So therefore, you would be able to separate. I want to see the disk counters for each one of these guys individually, right? So right now we'll do the disk queues for 2 of them. Let's go ahead and do that. I'll say current disk queue. What the hell? I'll add that. D, E, and G. Okay, so I've got 4 individual disk queues here, right? Current disk queue for every single one of them. I'm going to hit the highlighter here so I can tell what I'm looking at, and they're all 0 because there's really no activity on this box. But let's say they weren't 0. How do I know when my disk queues are too high? Because getting a number is one thing, and knowing if that number is out of whack is another, right? So the short answer is there are a couple different ways to tell, and depending on who you ask, I'll give them to you in order of what you should care about, right? The best one, the most usable measure, is 2 per spindle. So what that means is for every physical disk you have in there, a disk queue of 2 is acceptable. If you start going over 2, then you have an actual queue that you need to worry about. So here I've got every single one of these guys here on the same spindle, right? So I could have a disk queue of 8 here, of 12 here, of 5 here, and a 5 here. So that's a total disk queue of like what, 30? So 20, 30, 8, 12, 5, and 5, so 8 and 12 is 20, so 30, yeah. So, I've got a total disk queue of 30, and even though these are in separate partitions, they're on one single spindle because they're logical partitions. So, I've got a big problem there, because for that entire single partition, my acceptable disk queue is 2. So I'm 28 over, right? And that's really the best way to go about that. Now, if you have a SAN system with a huge RAID, it's still the same thing. You still need to know how many spindles are in that SAN. You need to know how many spindles are in your partition. And so all you got to do is when you see that you have a disk queue of 30, then you just need to go to your SAN guy and say, okay, how many spindles are in this RAID? You may find that you're running a RAID 5 with 10 spindles, in which case the acceptable disk queue is 2, because it's the spindle times 2, right? And in which case 30 is still unacceptable. I mean, I've seen, disk queues of, 200 that were acceptable, because we had enough spindles in the cabinet to make that to make that call, to make that balanced out. You don't see that very often, but if you've got 400 or 600 spindles in your RAID, then yeah, you could easily see 1 and 200 disk queues and have it be just perfectly acceptable. There's nothing wrong with that. Does that mean that you can't get it down? Absolutely not. But that means that you don't really have that much to worry about. So if you go by 2 per spindle, that's a really, really good measure, and it's industry standard. Most people use that. Actually, I take that back. Most people don't know what the appropriate measure is, but now they will, hopefully. Another way to do it is to say 2 per CPU, which I think is a lot less accurate. But if you have no idea how many spindles you have in your SAN, and you have no idea who to ask, you can use 2 per CPU. It's not very accurate, but it is something to go by. I don't like that one as much, but if you have to, then go by that, and it'll give you something. The third one is an equation that I don't remember right now. If I bothered doing any research on this, I'm sure I could find it rather easily. But that one's a little bit harder, because you need to know, the published numbers, performance numbers for that particular hard drive from the manufacturer, and then you need to plug that in, and then you need to plug that into a formula that will tell you what the exact acceptable amount of disk queue is for that spindle. And I'm sure it gets a lot more complicated than that too, because you probably need to take in, your RAID controller, and you need to take in, all types of other numbers to be able to get that to come out 100% and find out exactly what the acceptable disk queues are for that particular hard drive. And you need to do that for every single server if you guys aren't, standardizing on hard drives. So you can see why 2 per spindle is just a lot easier to keep up with, and it's a nice generic number, right? You don't have to snipe this thing. I mean, you're not trying to clip the wings off of a fly from 100 yards. You're just trying to hit a watermelon from a couple hundred feet. It's really not that big of a deal. So anyway, that's how to interpret disk queues, and that's more or less how to tell which when you have a disk queuing problem. And I hope this solves a question for a lot of people, because I see it in the forums all the time, and I personally get asked this all the time. So maybe some of you guys will be able to watch this video and understand what's going on here. And if you guys get asked that question, then point them to this video and say, watch this and watch the whole series. Anyway, take care.